Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. So today we are going to look at Calculus 2 and our topic is on u-substitution, that is based on the definition of integration as the reverse process of differentiation. And under this topic, we are going to look at the third form of integral, where the integrand is g prime of x times f of g of x. So when you have this kind of integrals, this is how you are supposed to begin. You say let u to be equal to g of x. You see what is inside the bracket? That is g of x. That's what you say. Let that be u. So this is our substitution. We need to know the derivative of u with respect to x. So this means that du dx, that is equals to g prime of x. Or you can make du the subject so that du is equals to g prime of x dx. I've cross multiplied. So when you substitute u, you must also be able to know the corresponding differential, that is du, so that we convert our integrand to now a function of u. So when we substitute that into the given integral, we'll have this. It will be equal to the integral. Remember, where there is g prime times d of x, that is what we are calling du. So we'll have f of u du, where we have said du is the product of g prime of x and d of x. And if you know f of u, it will be easy for you to find the integral. So I'm going to look at specific examples. Remember here there's a constant c of integration. For example, you can write examples. Let's say you've been asked to evaluate the following integrals. In part A, we have the integral of x times sine x times sine 6 minus 3x squared. Integrate with respect to x. So how do you go about this one? You start by saying let 6 minus 3x squared to be equal to u. So you say let u be equal to 6 minus 3x squared. So what about du? Du dx, that will give us negative 6x. You can also make dx the subject. So dx in this case will be equal to du over negative 6x. So we are going to make these two substitutions. U is equals to 6 minus 3x squared, and dx is equals to du over negative 6x. So when you substitute into the given integral, we'll get the integral of x times sine u. Instead of dx, we write du over negative 6x. So you see this x will cancel with this other x. So what we have is negative 1 over 6 times the integral of sine u du. At this point, you need to ask yourself that what did you differentiate to give you sine u? It is negative cos u. So that will be negative 1 over 6 times negative cos u. That's when you integrate sine u. Negative cos u. Then there's a constant c of integration. This you can as well write as 1 over 6 x cos u plus a constant c. And you need to replace u. We defined u as 6 minus 3x squared. So our answer is 1 over 6 cos 6 minus 3x squared, then plus a constant c. So you see in this case, what you are calling f of u, in this case it is sine u, which you know how to integrate. Another example, we can call it part B. And in part B, you're given this integral. Let me write it down. You are told to evaluate the integral of cosine of root x, everything over root x dx. How do you do this? You are going to say let u be equal to root x. Remember, root x is the same as x raised to 1 over 2. So we need to differentiate this du dx. This is the same as 1 over 2 times x raised to negative 1 over 2, which you can also write as 1 over 2 root x. So make dx the subject. So dx will be equal to 2 root x du. Now we have these two substitutions. Where there is root x, we are going to substitute u. And where there is dx, you are going to put 2 root x times du. So let's go back to our integral. If you make those substitutions, you are going to get the integral of cos u over root x, of course this is u, times 2 root x du. This root x will cancel. So we now talk of the integral. Of course 2 is a constant, so we write 2 outside, then times the integral of cos u du. What did you differentiate to get cos u? It was sine u. So when you integrate cos u, you get sine u. So this answer will be 2 sine u. I can put that in bracket, plus a constant c. And you have to replace u. Check where we defined u. Where there is u, you put root x. So this is the same as 2 times sine of root x plus a constant c. Another example, in part C, you are asked to evaluate the integral of sec squared of 7x minus 1 dx. So what do we do here? We say let u be equal to 7x minus 1. Let me write that. Let u be 7x minus 1. So when you differentiate, you get du dx. That will give us 7. If you make dx the subject, we are going to get dx is equals to du over 7. So our substitutions are these ones. U is equals to 7x minus 1. And also dx is equals to du over 7. Back to our integral. When I substitute, I'll get the integral of sec squared of u times du over 7, which is the same as 1 over 7 integral of sec squared u du. So what did you differentiate to get sec squared u? Remember, when you differentiate tan u, you get sec squared u. So that means when you integrate sec squared u, you get tan u. So our answer will be equal to 1/7 tan u plus a constant c. And when you replace u, you get 1/7 tan of 7x minus 1 plus a constant c. You see, these integrals are very simple. As long as you know which substitution you're supposed to make, then your work becomes very, very easy. I'll give you another one. We call it part D. Part D, you're given this integral. So we write part D, the integral of cosec squared of 4x dx. As usual, let 4x to be equal to u. So you say let u be equal to 4x. You need to differentiate, get du dx. That will be equal to 4. And make dx the subject. So dx will be equal to du of 4. So when I substitute, I'm going to get the integral of cosec squared u times du over 4, which you can also write as 1/4 integral of cosec squared u du. So what did you differentiate to get cosec squared u? Remember that derivative of cot u gives you negative cosec squared u. So for you to integrate cosec squared u, the answer will be negative cot u. You take note of the negative, take care of that negative, so that our answer here will be 1/4 times negative cot u plus c. And replace u, so we get negative 1/4 times cot, our u is 4x, plus a constant c of integration. Another example, you are asked to evaluate this integral. Let me write it. It is the integral of tan 5x minus 2 dx. Very easy again. Let u be equal to 5x minus 2. Let u be 5x minus 2. So when I differentiate, I get du dx to be equal to 5. Or you can make dx the subject. That will give you du over 5. Now, let's substitute those two into our given integral. When I substitute here, I'm going to get the integral of tan u du over 5, which is the same as 1/5 the integral of tan u du. Ask yourself, what did you differentiate to get tan u? What gave you tan u? Go back to our derivatives or the integrals. Already I told you how to integrate tan u, and our answer, I told you we dealt with tan x. The integral of tan x was ln sec x plus a constant c. That you need to take note of. So we expect our answer here, because now instead of x it is u, is now 1/5 ln or ln of sec u plus c. When you replace u what do we get? We get 1 over 5 times ln of sec. Our u is 5x minus 2. And then there's a constant c of integration. Another example is part f. Let me write it. The integral of x minus 1 multiplying cot x squared minus 2x minus 1 dx. So, which substitution are we supposed to make? What should be u? Check whatever is inside the bracket. Let that be equal to u. So this one here, that will be u. So let u be equal to x squared minus 2x minus 1. So we need to differentiate. This means du dx, that will give us 2x minus 2, which you can also write as 2 times x minus 1. So make dx the subject. So this means that dx will be equal to du over 2 into x minus 1. Then, when you substitute into the given integral, what are we going to get? It will now be the integral of x minus 1 times cot u. Instead of dx, we write du over 2 times x minus 1. So when you simplify, you see x minus 1 will cancel with this other x minus 1. And 1 over 2 is a constant which you can factor out, so that you'll have 1 over 2 times the integral of cot u du. When you integrate cot u, what do we get? I also told you that the integral of cot x should be equal to negative ln of, remember what we did, it was negative, there was no negative in this case, it was ln of sine x. We already derived that in the previous class. So this will now give us 1 over 2 ln of sine u plus a constant c. 1 over 2 ln sine u plus a constant c. So you need to replace u. So our u in this case is x squared minus 2x minus 1. So when you make that substitution, we are going to get our answer as 1 over 2 ln of sine of x squared minus 2x minus 1. That is u. And then there's a constant c of integration. I'll give you 2 more examples. Another one, let's call it part G. Here you are asked to find the integral or evaluate the integral of 2x times, excuse me, 2x times sec of 4x squared plus 5. dx. So what is our u? U is equals to 4x squared plus 5. So you say let u be 4x squared plus 5. When I differentiate, you get du dx. That is equals to 8x. Make dx the subject. That will give us du over 8x. So go back to your integral, substitute those two, the u and the dx. That will give us 2x times sec u. Instead of dx, you write du over 8x. So simplify, 2x will go into 8x 4 times. So we'll have 1 over 4 times the integral of sec u du. What is the integral of sec x? I gave you that when you integrate sec x, it should give us ln of sec x plus tan x. Similarly, the integral of sec u should give us natural log, or what we say ln of sec u plus tan u. So this is equals to 1 over 4 times ln, natural log, of sec u plus tan u. And then there's a constant c of integration. If I replace u, I am going to get 1 over 4 ln of sec. What is our u? Is 4x squared plus 5. Plus tan 4x squared plus 5. And you add the constant c of integration. If you don't know these simple integrals, then you can refer to your SMP table. You'll find all those integrals listed in the SMP table. The last example is part H. Part H, that is the integral of cosec 2x plus 3 dx. So how do we begin? We say let u be 2x plus 3. Let u be equal to 2x plus 3. So get du dx, that will give us 2. You can make dx the subject. So in this case, dx will be equal to du over 2. So back to our integral, we are going to get the integral of cosec u times du over 2. And you see 1 over 2 is a constant. You can factor that out so that you get 1 over 2 times the integral of cosec u du. So what do you get when you integrate cosec u? Recall from the previous lesson that the integral of cosec x is equals to negative ln cosec x plus cot x. Now when you integrate cosec u, it will be negative ln of cosec u plus cot u. So this is equals to negative 1 over 2 ln of cosec u plus cot u, and then plus a constant c of integration. When you replace u, you get this. You get -1/2 times ln of cosec. Our u is 2x plus 3. 2x plus 3, then plus cot. The same u is 2x plus 3. Then we add a constant c of integration. So these forms of integrals are very easy as long as you know the substitution that you're supposed to make. So for you to be able to understand this concept better, look for more examples or exercise. You try, work it out on your own, and then check with the answers if they're available. So thank you all for watching. This is the end of my lesson today. Don't forget to subscribe to my channel. Also, don't forget to share, like, and comment on this video. Bye-bye.